ஹலோ ஃப்ரெண்ட்ஸ், இன்றைக்கி நம்ம பார்க்க போகிறது ஐஇஎஸ் இந்தியன் இன்ஜினியரிங் சர்வீஸோட மெக்கானிக்கல் இன்ஜினியரிங் டாப்பிக்கில் இதில் மெக்கானிசம் அண்ட் மிஷின்ஸ் அதை பற்றி பார்க்கலாம். இதில் டாபிக் பார்க்க போகிறோம்னா கியர்ஸ். ஃபர்ஸ்ட் கியர்னு என்னென்னு பார்த்துடலாம். A gear is a rotating circular machine part having cut teeth or in the case of a cogwheel or gear wheel inserted teeth called cogs which mesh with another tooth part to transmit torque. Gear may also be known informally as a cog. An advantage of gear is that the teeth of the gear prevent slippage. இப்பனா ஒரு டீத்துக்கு இன்னொரு டீத்துக்கு ஜாயிண்ட் ஆகி மூவ் ஆகுது. A gear is a type of machine element in which evenly spaced teeth are cut around cylindrical or conical surfaces. By interlocking a pair of these elements, they are used to transfer rotation and forces from the drive shaft to the driven shaft. Gears can be classified by shape as involute, cycloid and tracycloid gears. They can also be classified according to shaft positions as parallel shaft gears, intersecting shaft gears and non-parallel and non-intersecting shaft gears. The history of gears is old and the use of gears appears as early as ancient Greece in BC in the writing of Archimedes. First, nomenclature of gear என்னன்னு பார்த்தலாம். addendum circle, addendum, clearance, pitch circle, root circle, dedendum, fillet, flank, face, circular thickness, space width, face width. இப்போ இதெல்லாமே பார்த்து இண்டிவிஜுவல் டாபிக் என்னன்னு பார்த்தலாம். ஃபர்ஸ்ட் addendumனா என்ன பார்த்தலாம். The radial distance between the pitch circle and the top of the teeth with the addendum. Next, arc of action is the arc of the pitch circle between the beginning and the end of the engagement of a given pair of teeth. Next, arc of approach is the arc of the pitch circle between the first point of contact of the gear teeth and the pitch point. Next, arc of recession, that arc of the pitch circle between the pitch point and the last point of contact of the gear teeth. Next on the backlash, play between meeting teeth. Next on the base circle, the circle from which is generated the involute curve upon which the tooth profile is based. Next on the center distance, the distance between centers of two gears. Chodal addendum, the distance between a chord passing through the points where the pitch circle crosses the tooth profile and the tooth top. Next on the chodal thickness, the thickness of the tooth measured along a chord passing through the points where the pitch circle crosses the tooth profile. Next on the circular pitch, millimeter of pitch circle circumference per tooth. Next on the circular thickness, the thickness of the tooth measured along an arc following the pitch circle. Next, clearance, the distance between the top of the tooth and the bottom of the space into which it fits on the meshing gear. Next on the contact ratio, the ratio of the length of the arc of action to the circular pitch. Next on the dedendum, the radial distance between the bottom of the tooth to pitch circle. Next on the diametral pitch, teeth per mm of diameter. Next, face, the working surface of a gear tooth located between the pitch diameter and the tooth top of the tooth. Next, face width, the width of the tooth measured parallel to the gear axis. Next, flank, the working surface of a gear tooth located between the pitch diameter and the bottom of the teeth. Next, wheel, larger of the two meshing gear is called wheel. Next on the pinion, the smaller of the two meshing gears is called pinion. Next, land, the top surface of the tooth. Next on the line of action, that line along which the point of contact between gear teeth travels between the first point of contact and the last. Next module, ratio of pitch diameter to the number of teeth. Next வந்து இந்த pitch circle diametral pitch அடுத்த pitch point னு பார்த்தலாம். Pitch circle, the circle the radius of which is equal to the distance from the center of the gear to the pitch point. Next, diametral pitch, ratio of the number of teeth to the of pitch circle diameter. Next, pitch point, the point of tangency of the pitch circles of two meshing gears where the line of centers crosses the pitch circles. Next, இது வந்து pressure angle profile shift ratio ன்னு பார்த்தலாம். Pressure angle, angle between the line of action and a line perpendicular to the line of centers. Next வந்து profile shift, an increase in the outer diameter and root diameter of a gear introduced to lower the practical tooth number of achieve a non-standard center distance. Next, ratio of the numbers of teeth on mating gears. Next on the root circle, root diameter, working depth. Root circle, the circle that passes through the bottom of the tooth spaces. Next, root diameter, the diameter of the root circle. Next, working depth, the depth to which a tooth extends into the space between teeth on the mating gear. Next, types of gears. First, spur gear, helical gear, rack and pinion gear, bevel gear, spiral bevel gear, screw gear, double helical gear, herringbone gear, hyboid gear, mitter gear, worm gear, internal gear. இந்த 12 gear பத்தி பார்க்கலாம். First, spur gear. Spur gear are one of the most popular types of precision cylindrical gears. These gears feature a simple design of straight, parallel teeth positioned around the circumference of a cylindrical body with a central bore that fits over a shaft. Spur gear are used in mechanical applications to increase or decrease the speed of a device or multiply torque by transmitting motion and power from one shaft to another through a series of mated gears. Spur gears are used to transfer motion and power from one shaft to another in a mechanical setup. This transference can alter machinery operating speed, multiply torque, and allow for the fine-tuned control of positioning system. இது ஸ்பர் கியர். இது பார்த்தீங்கன்னா டீத் பார்த்தீங்கன்னா ஸ்ட்ரெயிட்டாக இருக்கும். ஒரு டீத் கூட ஸ்ட்ரெயிட்டாக மேட்ச் ஆகிற மாதிரி இருக்கும். இதுதான் ஸ்பர் கியர். Next is helical gear. Helical gears are one type of cylindrical gear with a slanted tooth trace. Compared to spur gears, they have a larger contact ratio and excel in quietness and less vibration and are able to transmit large force. A pair of helical gears have the same helix angle but the helix hand in opposite. The teeth of a helical gear are set at an angle relative to the axis of the gears and take the shape of a helix. This allows the teeth to mesh gradually, starting as point contact and developing into line contact as the engagement progresses. இது helical gear. இந்த helical gear பார்த்தீங்கன்னா ஸ்லைடிங்காக இருக்கும். டீத் ஃபுல்லாக இது கூட மெஷ் ஆகி வர மாதிரி இருக்கும். Next, rack and pinion gear. Gear racks are utilized to convert rotating movement into linear motion. A gear rack has straight teeth cut into one surface of a square or round section of rod and operates with pinion, which is a small cylindrical gear meshing with the gear rack. Generally, gear rack and pinion are collectively called rack and pinion. The rack and pinion gear. Next, bevel gear. A bevel gear is a toothed rotating machine element used to transfer mechanical energy or a shaft power between shafts that are intersecting either perpendicular or at an angle. This results in a change in the axis of rotation of the shaft power. Aside from this function, bevel gears can also increase or decrease torque while producing the opposite effect on the angular speed. இதுதான் bevel gear. The number of teeth of the driver and driven gear are usually different to produce a mechanical advantage. The ratio between the number of teeth of the driven to the driver gear is known as the gear ratio, while the mechanical advantage is the ratio of the output torque to the input torque. Next one, the spiral bevel gear. Spiral bevel gears are bevel gears with curved tooth lines. Due to the higher tooth contact ratio, they are superior to straight bevel gears in efficiency, straight, vibration, and noise. On the other hand, they are more difficult to produce. Also, because the teeth are curved, they cause thrust forces in the axial direction. Within the spiral bevel gears, the one with zero twisting angles is called zero bevel gears. Next on the screw gear. Screw gears are a pair of same hand helical gears with a twist angle of 45 degrees on non-parallel, non-intersecting shaft. Because the tooth contact is a point, the load carrying capacity is low and they are not suitable for large power transmission. Since power is transmitted by the sliding of the tooth surfaces, it is necessary to pay attention to lubrication when using screw gears. There are no restrictions as far as the combinations of a number of tooth. Next, double helical gears. இந்த double helical gears இந்த ரெண்டு சைடும் gears வந்து sliding இருக்கும். Next, double helical gears are a variation of helical gears in which two helical faces are placed next to each other with a gap separating them. Each face has identical but opposite helix angles. Employing a double helical set of gears eliminates thrust loads and offers the possibility of even greater tooth overlap and smoother operation as the helical gear. Double helical gears are commonly used in enclosed gear devices. Next, herringbone gear. Herringbone gears are very similar to the double helical gear, but they do not have a gap separating the two helical faces. Herringbone gears are typically smaller than the comparable double helical and are ideally suited for high shock and vibration applications. Herringbone gearing is not used very often due to its manufacturing difficulties and high cost. Hypide gear. Hypide gears look very much like spiral bevel gear, but unlike spiral bevel gears, they operate on shafts that do not intersect in the hypoid arrangement because the pinion is set on a different plane than the gear. The shafts are supported by the bearings on either end of the shaft. Meter gear. Next, meter gears are bevel gears with a speed ratio of 1. They are used to change the direction of power transmission without changing speed. There are straight meter and spiral meter gears. When using the spiral meter gears, it becomes necessary to consider using thrust bearings since they produce thrust force in the axial direction. Besides the usual meter gears with 90-degree shaft angles, meter gears with any other shaft angles are called angular meter gears. Next, worm gear. A screw shape cut on the shaft is the worm. The mating gear is the worm wheel, and together on non-intersecting shafts is called a worm gear. Worms and worm wheels are not limited to cylindrical shapes. There is the hourglass type which can increase the contact ratio, but production becomes more difficult. Next, internal gear. Internal gears have teeth cut on the inside of cylinders or cones and are paired with external gears The main use of internal gears is for planetary gear drives and gear type shaft couplings. There are limitations in the number of teeth differences between internal and external gears due to involuntary interference, trachoid interference, and trimming problems. இது internal gears. வந்து the outer gear குள்ள inner gear, the internal gear. Okay friends, further video further topic பத்தி பார்க்கலாம். Okay, thank you.